Now the topic of this lecture is comparison of inertial frame and non-inertial frame methods. We have taken a few classes on pseudo forces and the examples of them, but we still believe that students continue to have confusion regarding pseudo forces and they can't decide whether they should solve the problem, a mechanical problem, inertial frame or in non-inertial frame. Hence, we shall take some more examples of these two types of approach and see their equivalence in a number of cases. First of all, let us recall what we said earlier regarding inertial frames and non-inertial frames. A frame of reference is visualized in terms of a coordinate system. So let's consider a coordinate system here OXY, and this frame of reference will be called an inertial frame if Newton's laws are valid in such a frame. Let me consider one more frame of reference here, and that I shall name O dash X dash Y dash for distinction. And this new frame O dash X dash Y dash, if it remains at rest with respect to OXY or moves with a constant velocity, which means acceleration of the frame O dash X dash Y dash is a null vector with respect to OXY, an inertial frame, then the second frame also, O dash X dash Y dash also turns out to be an inertial frame in which Newton's laws will be valid. On the other hand, if the frame O dash X dash Y dash has an acceleration, suppose we call it A0 and that I take to the right, and this is not 0, it's not 0 here. In such case, O dash X dash Y dash is having an acceleration with respect to OXY, that was inertial frame, and this frame will be called a non-inertial frame of reference. So once again, an inertial frame is one in which Newton's laws are valid, a non-inertial frame is one in which Newton's laws are not valid, and a frame will be non-inertial if it has an acceleration, a non-zero value with respect to an inertial frame of reference. Now if we investigate a particle, say P, I just introduce it in my figure, and let's say this particle, I name it P and its mass is m. Now if you observe this particle P from the inertial frame of reference, since Newton's laws are valid, if you want to write the equation of motion for this particle, we know equation of motion comes from second law that says that the net force, net unbalanced force acting on a particle is given by mass into acceleration. When you observe this particle P from the inertial frame of reference, here F net is standing for the vector sum of all the real forces acting on the particle P. Real forces means particles which have got an identifiable origin, like gravitational force, normal force, tension force, electrical force, and so on. On the other hand, if you want to investigate the motion of the particle P in a non-inertial frame of reference, since Newton's laws are not valid in the frame, we have to modify the meaning of F net. F net will be turning out to be the vector sum of all the real forces acting on the particle P, as well as one additional pseudo force that will be directed to the left in my figure, and this pseudo force, let me write it, this is Fp for pseudo, it will be given vectorially by minus mass of the particle P into acceleration of the frame O dash X dash Y dash from which the particle P is being observed. This is the pseudo force, as I said. So once again, when we write equation of motion of particle P from inertial frame OXY, we just mean by F net the sum of all the real forces acting on the particle P. But while we write equation of motion of particle P in the O dash X dash Y dash non-inertial frame, F net means the summation of all the real forces plus one pseudo force given by the product of the mass of the particle and the acceleration of the frame O dash X dash Y dash, and its direction is exactly opposite to the acceleration of the frame O dash X dash Y dash from which the particle P is being observed. Well, these things we have said before, so I shall just take a few examples, commonplace examples, and see how these events are explained by an inertial observer and a non-inertial observer. We shall take 3 cases here, and in the last problem we shall see how we can approach a problem from these 2 frames and arrive at the same result, which means both the treatments completely equivalent in physical terms. So the first example we shall choose here is a very commonplace event. That's a girl running past a tree. Now suppose here is a tree standing on the ground, is obviously stationary, and a girl is observing this tree from a distance standing on the ground herself. So let me introduce here a coordinate system attached to the ground in which the child is standing, and I shall name it OXY. This is my frame of reference, and this frame of reference is an inertial frame because it attached to the ground. We said before that when we investigate terrestrial phenomena on or near Earth's surface, we can attach a frame to the ground and consider that frame to be inertial, in which Newton's laws are valid. So how does the girl, whom we shall call an inertial observer, explain the tree's position and being at rest? According to this girl, there are 2 forces acting on this tree. One is downward force of gravity. If the mass, suppose the mass of this tree is taken to be m, so according to her there is a force of gravity downwards and a normal force given by the ground upwards, and these 2 forces cancel each other out, because of which this tree has got no vertical motion. According to this child, this girl, there is no horizontal force acting parallel to the ground acting on this tree, and that's why, since there is no force acting on the tree in the horizontal direction, there is no horizontal motion of the tree, and the tree is at rest. So the inertial observer, this is the inertial observer I have shown in the figure, that is the girl standing stationary onto the ground and observing the tree. She argues that since we know that Newton's second law says F is equal to m into A, and since there is no horizontal force acting on this tree, so the acceleration of the tree in horizontal direction also is 0, and in this case it means the tree is at rest. So no force, no acceleration, and no motion. That's according to the girl standing stationary onto the ground and observing the tree. Now in case this girl now starts running in the rightward direction, let me draw that figure here. So here is the same girl that begins to run in the rightward horizontal direction, and you know that according to this girl now, the tree appears to run backwards with an acceleration of the same value as herself, but in the leftward direction. So suppose what we do is that we introduce another frame of reference attached to this girl's body.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.